syntax for this? Oh. Well, that's not really a Python code. Okay. A natural number is called k prime. Let's call weight of a number of the number of digits. For example, 99 will have weight 18. 100 will have weight 1. Okay, for each number in string, calculate its weight and then find two numbers of string that have smallest difference of weights, i.e. that are closest with the smallest weights. And the smallest indices, or ranks numbered from 0 in string. For each number in string, calculate its weight and then find two numbers of string that have the smallest difference of weights with the smallest, I don't get it. Output, an array of two arrays, which each subarray in the following format. Number weight, index of string of the corresponding number, original corresponding number in string. String equals this, okay? Weights are 4, 6, 16, 18, and 2, i.e. 2, 4, 6, 16, and 18, okay? Closest should return 2, 4, 2000, 4, 0, 103. I'm not sure I understand what they're looking for here. Let me go into the problem here. It might be a little bit easier to... Okay. They're going to give me numbers. Okay, the output is an array of two arrays, each subarray in the following format. Okay, number, weight. $13.9. Number weight, okay. Index in string of the corresponding number, which is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 85. And then that number. And then 14. Okay, so the two numbers that are closest together. Okay. All right. I get it. Okay, so... Well, first thing we'd have to do is probably break apart this string, right? We got to split apart this string and find out what each element weighs. So they're all separated by spaces, so a really handy way to do that would be split. So we'll just say new string equals original string. I'm going to put that I in there because that's going to confuse me the whole time. I don't know why they took it out. So new string equals original string split. And we want to split it by spaces, which is the default splitter anyway. So that would look like this if we wanted to, but we can just leave that blank because it's default. So that's going to be splitting them all up. What I'd like to do is take some of this and work with it in a different program here, so that it's a little bit easier to test. I'm going to use Solo Learn Code Playground. Okay. Okay. How's the music? Is the music good compared to my voice? Should I turn it down? Turn it up? Alright. So let's just take what they gave us here, and let's transfer that over to our playground here. Let me zoom in a little bit so you guys can see the code. We don't need a huge output. Okay, and we need some way to test it, so we're going to add some print statements down here on the bottom. Print. And we're going to take that first test they gave us. Closest. Just like that. Alright. Now, we're going to need a little bit more room here. Okay. Now, if you are new to this, closest is the name of our function, and this is the argument we're passing it, which is also called string. And so this is what's going to get split up. Right now, if we were to give this function something to return, we'd say return n string, and you can see what this split has done to it. Return n string. Let's make sure that music keeps going. Alright, now if we hit run on this, you'll see it's going to give us all those values separated. And we can even print them out, you know, for each line here. Okay. For I in n string, print I. And then now we can see them all in separate lines. Okay, so these are the items split up. We need to get a weight for them. Right now they're still in strings. So for I in n string, we're going to say we want to grab each one of the individual numbers that are in those numbers. So if we just turned them to an integer now, by using the int, if we just turn them into an integer now, then they're just going to be that big number. There's no way to add them all together. So we're going to have to iterate through each one of those first. So let's make this a little bit more easy to understand here. So how about for item in n string, and then we'll say for number in item. So this is going to break it down one level. We're going to say item weight is going to equal plus equals it. This will increment it each time we go over the item. Item weight plus equals num, and this is where we want to turn it into an integer. Item weight plus equals integer. Okay, and then now we're going to want to do something with that item weight after it's done for each number. So at this point we're going to say let's make a variable for this. We're gonna add that to a new list, which we're gonna call wait list. And for now we'll just initialize it blank, and then every time we get through each number we're gonna have to add that weight to it. We're gonna have to add that weight to it. So item weight, and this is a list, so we're gonna have to append no, wait list, sorry. This is gonna be the list itself, wait list, and we're gonna append it with the item weight. Okay. Now at the end of all this, we're going to return, just to see what kind of progress we're making here, we're going to return the wait list and see what we get here. And we should get each item's weight. Local variable item weight referenced before assignment. Item weight. Okay, we need to initialize that. Thank you. So we want to reset this item weight every letter, so, or every item in the list. So item weight here is where we're going to initialize an empty number. Let's try that. There we go. So now we've got the weight of all the items. Let's double check. Let's double check just to make sure. Let's print the original first item and add it up ourselves. So right here we're going to print the original item, or after we split it anyway, n string the first item, which is the 0th position, which is 456899. Okay, so that doesn't make any sense because there's no way that adds up to 9. For num in item, item weight plus equals in num. Weight list dot append item weight. Okay, I'm sorry. This is resetting it back to 0. You see the last digit's 9, and it only had a value of 9. So this item weight equals 0 is resetting it after the 4, resetting it after the 5, resetting it after the 6, and so on. So we want it to actually reset it one level higher than that. So while still in the particular item, in this 456899, before it moves to the next one, that's where we're going to want to reset the value of this. So we're going to move this up And this should give us the correct item weights now. There we go. So 4 plus 5 is 9, plus 6 is 15, plus 8 is 23, plus 9 is 32, plus 9 is 41. Okay, so we're right there. So it's adding them up correctly. So now we have the weights, and we need to figure out which are the closest to each other. Closest to each other. It's going to take some math, I think. What do you think? What's the best way to figure out which two of those numbers is the closest to each other? Well, minus them, and then whatever the difference is, I guess. Minus the two numbers and find the difference. Whatever difference is the smallest. There's no reason we need to keep differences. Well, the question is, we've got these weights here on the right hand side, okay, and these are the individual numbers printed out here. Let me make this a little bit easier to see. So let's just print the individual numbers, and I'll show you what I mean. So these are the individual numbers given to us down here. Actually, I don't need to print them, they're already there. And you'll see that if we add up this number here, add up every digit in that number, it equals 41. And that's what this problem is calling, that's what this problem here is calling the weight of it. So all those numbers added up are 41. 5 and 0 added up is 5. All these numbers added up is 22. What we need to find out is the smallest difference between any of these weights. I think that's going to take math. Let's see. It's definitely going to take math. Like if I went, if I made a separate list that was for weight differences, but I don't want to lose this spot. I don't want to lose the position of the original weight. Could map it. Could map it to give me an index. Let's see. Man. Alright, we've got the weights. We just got to figure out the difference between them. I just want to try this out here, because if I did this, if I went ahead and sorted this list, I'd lose my position, but I just want to see this. I got to believe these two right in the middle are the smallest difference, right? It's got to be the middle value. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. it's gotta be the middle value. I guess not necessarily. Because this could be like 39 and 40 over here. Well, it's not a very long list. As the list grows, it's going to get more resource intensive, but it's not a very long list. We could just iterate through the list and subtract it from everything and add it to a dictionary. Okay. Let's see. All right. Anybody that's good at math. There's got to be a calculated way to. I mean, so let's. I mean, I could iterate it through them, like for item in wait list. It seems like a waste of resources. For item, because then I'd have to iterate over it twice. Could minus it. Well, I've got a set of. Let me unsort this. I got a set of numbers. Okay. I've got to subtract each one of those from each other and find the two numbers that have the closest difference. Like the smallest difference between any two of those numbers. I need to come up with the two of those numbers that have the smallest difference between each other. I mean, obviously, it's easy to do it by your brain. You know, if you look 24 and 25, obviously there's only a difference of 1 there. That's probably the 2. But there's got to be a mathematical way to do it. Let's do a little research here. So let's do a little research. Let's say comparing 2 numbers in a list. Right? Because that's what we need to do. Comparing lists and the 2 most popular methods are set in 2 adjacent items in the same list. I'm searching for a way to compare 2 adjacent items. Okay, I thought this was going to be an easy one too. It is easy, I'm just missing, I think. I'm missing the easiness in it. I probably need to do this and use a number iterator. I minus I plus 1. And then increment I. I need to increment this first one by the whole list. I need an incrementer that moves. So if we said all right. Let's separate out this functionality. That way we don't get confused. Okay, so this function within a function, we'll call it, is to split and weigh. Split and weigh, and we're going to be offering it the string. So let's just do that. Now we have another function that is going to compare weights. I think I want to hand this end string because I want to be able to use it for the other function. So we're going to back that out into here. Okay. And this is going to get probably wait list. So this function's gonna return the wait list. This one's gonna take in the wait list. Okay. Can you hear Lola? In the background. She's begging to go outside. Begging to go outside. Okay. We might need to take a step back from this one for a minute. Lately she's been eating lizards and stuff that she finds out there. Okay. Comparing weights. No, probably not. Beats me. Alright. Easier. Really, I'm gonna need to store the difference between the numbers so that I can compare them and find the lowest. Or at least see if that's the new low. Okay. So let's see if I had... First, let's implement this. So we're going to take string and we're going to split and weight in string. And then we need to pass that to compare weights. I want it to give me the indice of the weight too. I'm going to need that to get the original numbers. So I need this to be a number. So instead of for I in wait list, because then it'll be that number, I need it to be the index number. So we're going to say for I in range length of wait list. For I, so just to show you how this works, if I went print wait list position I, now that I'm using an indice like that, it should just print all the numbers. Missing a parentheses for I in range len. Oh, missing an in. Sorry. There's all the numbers individually. So if I take that and I say each item I'm going to need to subtract from the next one and the rest of them. Yeah, that's an interesting question. I wonder how it handles the same weights. Does it say that? The smallest difference of weights that are the closest with the smallest weights. So that's how I'll have to handle that. 13 and 14 is going to be less than 14 and 15 because they're smaller weights with the smallest indices or ranks numbered from 0 in string. So it's the smallest difference among the smallest numbers among, and if that's still tied, then it's the first numbers to appear with the smallest indices. So we need to know the original indices, which is leading me towards map. That's what I wanted to do to begin with. A map function. Map function returns a map object, which is an iterator of the result. So I almost want a map function of... Can I map 3 things? Map list 1. Yeah, you need to tell it not only to read the list, but to keep track of the indice number. Because if I just run through that list and I start subtracting things from each other, I'm going to lose track of where in the list they were, and then I'll lose track of the original number. Basically what I want to do is subtract each number from every number in the list. And when I hit the lowest possible one, grab the 2 index places. And then once I have the 2 index places, I can revert it back to the original string. Because in there, they want me to return back the difference, or the actual weight, the index position, and what the original number was. So both original numbers, both their weights, and what position in the original string they were. That's harder than you think, to make sure that they're all the lowest. Like, I'm going to have to add these 2 indexes together, 1 and 5. Right? The smallest indices or ranks numbered. These are going to have to get added just in case there's any other ties. This is going to be a work in progress here. Depending on if this is done before dinner or not, this may not get finished today. So now that I have each number, I'm gonna try to get a difference for that number so if I said diff equals I minus are these strings? These strings? Print type of I. Let's just find out what they are. They're ints. Okay, so I don't need to turn them into ints. They're still ints. I think I did that up here. Okay. So diff equals I minus I plus 1. Really, those are the positions, so we need to tell it for I in range when it's just a number. So the first I number is going to be 0. So wait list position I minus wait list position I plus 1. That's just the next element. I wanted to do all the elements though, so let me just see what I get from this first. And we'll say print diff. Maybe if I spelled that right. List index out of range. Yeah, that plus 1's not going to work because obviously when we get into the last digit, there's no plus 1 after that. There's a way to solve that. I mean, there's just an if statement. If I equals len of wait list. We can say it does not equal, because once it hits that, it'll really? -1? Yeah, there you go. Okay. So, I got the differences here in just the first letter. This is just the first one minus the second one minus the third one minus the fourth one. We could say, because each one I'm gonna want to subtract for I, for J in range, len, wait list, because then it's going to go back through the list again. diff equals I minus, see, I don't want this to start. I don't want this to do itself. So how about if I does not equal j? Right? That way it will not multiply itself. Diff equals I minus j. And we'll start we'll start a counter, lowest so far equals 0 for now. So hold on, let me figure out a way to get my so diff equals I minus j. Print diff. I just want to see what we're working with before we get any further here. So we want to find the smallest one, right? So diff equals I minus j. Actually, absolute value of I minus j, because it's going to be negative, but the difference is still the absolute value. So diff equals absolute of I minus j. Okay. This cannot be 0 though. My two numbers, these two numbers minus each other. Oh, that's all anyone can hear is the cat meowing. I want to find out if there's a way to I gotta compare this. So this can't be 0 because that's going to be the lowest. We don't want this to be low. We want it so why don't we say if if not diff. We're just going to give this an initial value here so that we don't have to give it a number. If not diff, so I mean if we haven't already set a diff, then diff equals that. Else, if the apps of I minus j is less than diff, the current difference of where we're at, then we're going to do it again. We want it to keep track of that, of I. And j. We want to keep track of I and j. Okay, so at that point we want to say we want to keep track of I and j. So I'm going to put them in a dictionary. So weights dictionary. Key would be diff equals I and j. Actually, I kind of want a temp one, right? It can actually be just a list. So every time I move to a different number, I want to start a new temp list. And temp weights list dot append a list of lists. That's what we'll do. We're going to append a list of diff, I, and j. I'm going to do that again here. Okay. Now, before we exit it, before we add that to a dictionary, weights dictionary, which takes a key value pair. Let's see, before we add that, we need to take the lowest one. Well, that's why we want this to be a dictionary too, so I can sort it. That's why we want this to be a dictionary too. Key diff equals I and J. Okay. I think this is all gonna work. We're gonna try it here. We're gonna figure out if we're far off here in a second. We need to get a couple more lines together. Temp weight sticked equals, okay, so at this point we want to sort it. I just did that, but dictionary sorting by key, Python. Sorted key value dot keys. That gives me a list of keys that are sorted. Okay. In sorted key value keys. So we want the first key. How do I get the lowest sorted? I know how to sort that list. It gives me a list. Let's just see what it gives me first. Print sorted temp weight dicts. No S. Temp weight dict. There's an S there. It's not saving I or J. Or it's just giving me the keys. Can I say position 0? Which is the keys, the differences. We're making slow progress. We're making progress. We got the differences and we got them sorted. I'm pretty sure that the indices are along with those differences. I just gotta figure out how to access them. I gotta access the things. These are keys, right? These are keys. Right? If I went like this, print, and I just printed the whole dictionary, you'd see this is a key plus the two indices of the numbers. So watch. See? So we've got, and I could probably even tell you what the original numbers were. Here, watch. For num in, how about for key value, for key in temp wait sticked, print wait orig nums. No, there's two there. Let's just see if this works. Key. And the original values are going to be corresponding with the indices. So that would have been end string position actually I don't need that. End string values position 0 and in string values position 1. Cannot unpack non-iterable int object. Can I unpack? Can I go like this? Temp weights dict key. Can I do that? Value 1. Two. Put an S somewhere. Let me unpack it. Yep. Yep. There you go. That's progress. See, now we have the original number and the weight, but that's not right. That adds up to 5 and that adds up to 41. What's it minusing from itself? Oh, see, I'm minusing the indexes from each other instead of the weights, which are in the temp weights dict position I minus temp weights dict position J. Copy. Now this needs to be here too. Key arrow 0. Oh, it's a dictionary. I can't give it a list position. I'm just gonna make this a list. It's just easier. Can I sort it? Sort a list of lists by first element. One Steve, 4 Jane, 3 Frank, 2 Kim. See, that's what I want right there. Okay. That sort key equals lambda x. Should do the trick. Make sure you have the int cast as you can run into further errors with larger numbers because integers are sorted. We use by default, sorted will use the first element. Okay, so as long as we put the first element in first, then we can sort it. And then I don't have to look for a key. This is weights list. That's another snafu there too. What does this give me? Here we go. That looks right. There's only one way to tell. We're gonna have to sort it. Well, it's not sorted. I wonder why it won't sort that list. I'm just going to comment this out for right now so I can work on why this list isn't sorted. Print key. What? Not by... key value dot keys. That's what I did. Okay. Why is it not sorting that list? Pretty sure that's needed. Yeah, that's needed here. Still not sorted. Really? This is already making a list out of it. It's already making a list out of it. I'm just going to comment this all out for right now and figure out why this isn't sorting. Print sorted temp weight dict dot keys I don't get it. It's an integer. Why can't I sort it? This should all be one list. It's still not fucking sorted. I don't get it. I feel like I still don't know if those are the lowest values for that indice. So what that first thing is saying is that the lowest value for the first number, which is this number, is with the 10th item. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That cannot be right. That's 8. I gotta do some error checking here. I want to see what it's getting. That's not right. I gotta come up with this number a bunch. So let's assign it to a variable. Diff has to come down here. That's more like it. That's more like it. It's adding them all. Temp weights, diff. Is less than the difference. Then we need to reset the difference. Okay. It's giving me all the differences for that number, which is good. But I only wanted to keep the lowest one. Diff is getting reset here. Yeah, diff is not defined. At least I know it's not double adding. It's resetting diff and adding it to the dictionary every time. It should only be adding increasingly smaller values to the dictionary. Let's use a different item as the key. No, I want to use the difference. Let's not add it to the dictionary yet. Let's compare it with difference and figure out what's the lowest. Mosquito. Fly by my face. Okay. We're almost there. I feel like we are almost there. We've got weights, we've got indices. I just have to find a way to access them and sort them. So let's take a look at what we're actually storing again. Because if not diff is not working. I reset it here and it won't keep track of the current lowest. I don't want to store them all right away. Lowest needs to be low. How can we set it high to begin with? just say if j equals 0, if this is the first time it's starting off, set diff to false. Now if not diff should work. Now it should only go down in value. See? Down in value, then the next number. See? We got it. See? Down in value, then the next number. Down in value, then the next number. Perfect. So, now before I exit that for loop here, I want to save the lowest value. Now can I sort this? Yep. We figured it out. Now I can sort it. Okay. And now I just want to print the very first one. Let's look that up. Printing the first element in a dictionary. I guess, does it need to be a dictionary? It doesn't need to be a dictionary. Watch this. We're gonna switch it over to a list, I think. Okay. We're gonna comment out on some of this stuff too. We'll use proper commenting in a little bit as soon as we figure it all out. Okay. So if that's a list, right? Then diff apps waitlist I waitlist j. Waitlist is also a list. Okay. Okay, so let's list. Dot append. Dot append. Diff ij. There we go. Okay. We want to do the same thing down here. This doesn't need to be keys, and it should sort it. They said it was sorting it by the first value anyway. For key in sorted print. So for value, okay, in sorted. I shouldn't need this anymore. Should be able to just access them. Print. This is going to change to value position 0, which is going to be the first one, which is set for difference, as we can see from the right hand side. See, value position 1, which is going to be the original number, and then value position 2, which is going to be the other original number. Let's try that. Else. Oh, missing a parentheses. Okay. I'll also be missing a parentheses there too then. Compare weights. It's down there, so I'm missing a parentheses here. Yep. Gotta pay attention to your parentheses. Template stick not defined. Okay, for it's sorted templates list. See, you're gonna change something, it's gonna change everything. See? There we go. And those lists are sorted. Now, I only want the lowest one. Now, I want the original numbers here, not the indices. So this is going to be n string value 1. Right? And this is going to be n string value 2. This will give me the original numbers. There we go. And the differences in weights, which we can't see the weights anymore. But we do have them. We could probably difference 10. We're creating basically a test suite. So that we can make sure we're on the same path. Original first num. Original first num, and we're going to give it its weight. Watch this. Weight. Format. Now this is going to be n. This, well, we've already typed this out, so let's make life easier for us. Okay. And then we can do wait list. Same position because we didn't change the position. Oh, we did. No, the indice is in the value. The indice is in the value. Wait list value 1. And then we say print second num weight basically this line but we're going to change those to value 2s. And we're going to say just difference here. See that? And we're going to give ourselves a new line. Just to separate it all out. Now this will tell us all we need to know, that we're on the right path. It's not going to be what we want to return yet. Invalid syntax. I'm missing probably a parentheses somewhere. Yeah, print parentheses. Print parentheses here too. Okay. Oh. Isn't that new line? There we go. Sorry. Backward slash. First num this, weight 41. Second num that, weight 31. And you can see that that same number does all the other numbers and gathers a weight difference. And we sorted it down to the lowest weight difference for this number is this number. Now, once we get the lowest of each difference, we're going to want to find the lowest of those. It's a good thing we kept the indices as the values, because we're going to need to compare those two. So really this is not compare weights. Really this is compare weights, yeah. And then we'll have to do a compare indices. We want to pass it all the values that we have now. Okay. Okay, we can get rid of some of this debugging, print debugging that we were doing. Some of these extra spaces. And we can work on our next challenge here. So we know we have this in a list. I wanna print what it's passing to value. A difference in two original indices. So see how the second indice, or the second value in that list over here, that's that number. So we need the lowest first value for every 0, which is going to be 10. It's going to be the first one. And then we want it to iterate through this list until it says 1, and then grab this information. And then we want it to iterate to this through this list until it says 2, and then grab that information. Okay, so if value 2 we're going to initiate the final weights list now. Weights list equals if value 2 in weights list if it's not in the weights list, add that information because it'll already be in the weights list. I think I can do that. Sorted weight list position 0, which is the first item. Let's see if that works. Let's rename this because we don't want to get confused. Value. The whole value, all 3 things. Else, continue down the list. This is to be outside of this for loop, obviously. No, that's outside of this list too. That's in compare weights. Oh no, that's why that works. That's why it's running over and over and over again. I think this works. I think I just need to initiate this all the way up here. Okay. I think this works. Let's take out these print debugging statements for now. And then let's just print final weights list. See if we get just the lowest numbers for everything. List index at a range. Position 0. This is probably where I want a key. Am I not using the weights dict? I'm not using that. Okay. Right? Yeah, I'm not using weights dict, so I am going to make a dictionary. This doesn't need to be sorted. Value 2 not in I think this has got to be keys. Then we're going to say final weights list key value 2. I'm sorry, this is 1. If that's not a key, then make it 1. Add the whole value. Or else continue. Value 1. Value 1. Oh, stupid. Beep. Beep. One for each. Look at that. 1 for each. With the lowest difference. We're getting there. Watch this. We're right around the corner. Okay. So. Compare weights. Let's return this. return final weights list as a dictionary. We're going to make another function that's going to compare all the diction. Sort by key. Here's the key is the difference. I think if we just sort by key, it's going to pass all the tests. I get where they're going, where then I'll need to check the indices. I should be able to just add the two of them up. Oh, this doesn't match. Freaking. That's where I need to add them up. I need to add them up and add that to the list of information that's here as a fourth item in that list. Have the two indices additions together, and that way, because you see how I have 1 for 2, right? It means in the first spot I've got 2 difference, and it's between 1 and 10, right? There might have been another one with 2 difference in 1. I mean, we just grabbed the first one, and if it's not in the dictionary, it moves on. You know, it adds it, and if it isn't it, then it moves on. We just grabbed the first lowest one. Actually, we can actually see here. Let's we can see here. We'll add back these print statements. So 0, 10, 16. Let's look at 1. 1 and 2, 1 and 5. So nope, it won't work. That, you know, it's not. Can I scroll down? Can I not scroll down on that side of the? Interesting. I wish it would show me. I'm just worried about, like, if you see 1, 2, 1, 2, it's got another 2 difference. I'm worried about in the test cases. So I do want to come up with the combined indices to make sure we have the lowest indices, as the challenge says, with the smallest indices. So we do want to pay attention to that. So let me try that. Yeah, they're okay. They don't work. Nothing makes that scroll down over there. But that's okay. That's okay. I know what I'm doing now, and I know what I need to be doing here. So, okay. So somewhere in here, when we're making this list, equals value for value in sorted temp weights list. So in the temp weights list, append difference I and j. Okay, and then also I plus j. That'll be the indices together. Now watch what happens when we run this. Oh, because I'm returning, sorry. And I took my print statements out. Now we should have a fourth item in that list. I plus j. Append. Templates list append. Oh, I'm sorry. I gotta do the same thing down here. I plus j. Okay. Okay. Now let's see that. There we go. That'll give us the lowest possible thing. So if value not in, then else. Okay, so if it is in final weights, then we want to compare the two indices and only add it then. So which that's 0, 1, 2, 3. It's the third spot. So if the value already is in there, then we say if that's not the key. It is the key. I want to see what this looks like real quick. Let's get rid of all this print. Oh, sorry. Let's change this back to continue. Okay. I'm using the value as the key. And I'm going to need to sort it by that. Well, I don't have to add it all. I can just add the 1. Let me try to figure this out real quick. I'll try to think out loud. I'm using the first indice as the key, which is the original number, so that I can make sure I did all that out. But really, I'm only interested in the lowest number. So I should use that as the key. The difference. I'm only interested in the lowest difference. I should use that as the key. So that's 0. See? Now watch this. There you go. Now that's just the differences. This has to be 0 too. Now it's giving me a lot of zeros. for value and sorted temp. No, because I only need one per number. That was the reason why I was doing it in the first place. Alright. Okay. So that needs to be like that. Okay. This is each indice. But I want to make it so that it's if the number's in there, it also compares the indices. Okay, so if value 3 is less than, because we're looking for the lowest indices, then the thing that's already in there, so final weights list value 1 I think it's dot items. Zero, 1, 2, 3. Then overwrite that. Else continue. List object has no attribute item. So if this is the list object, can I specify that then? Position 3? Yep. That's not the lowest though, is it? This list looks weird. Let's see what that. Let's just see what this is. Actually, it's probably got to go underneath. Okay, yeah, I got a better idea. I'll put it right in here. Indices. Previous indices. Let's do that. Means it was already in there. Copy. So we'll see if it gets replaced. We'll say new indices. New indices. I'm missing a parentheses. Okay. I want to see what's happening at every step here. So print writing value to dictionary. Writing. I'm going to put it again down there too. Why is it writing 16? Okay. All right. Okay. I get it. We need another if statement here. If this is 0. We need to say this is the differences value. So we want, you can see over here, see we got 0 with a difference of 10. Position 0, which is the first number, with a difference of 10. Position 0, which is the first number, with a difference of 16. So we don't want to keep adding the first number if the differences are always higher. And they're always going to be higher because it's sorted. So as soon as we know that, so this would be value 0. If value 0 is less than final weights list value 1, value 0, then move on to the next step. Else, just continue. We getting there. We getting there. Okay. Okay. So now we have the lowest possible difference for each number in the array and what number that is. That's what we were looking for. Lowest possible difference for each number in the array and what number that's with. And their indice count, which should all be the lowest. Right? So we want to organize this by difference and then indice count. Yup. We could probably further if statement this so that it doesn't even add it to the dictionary. So we don't have to sort it. We could say the second value then add it. Really, we just gotta say I'm trying to figure out a way to that it would be possible to put an if statement on the value and the difference value. We don't need to write every number to it. Just need to write see, that's why I think if we go with using the difference as the key, if that is not, if the difference is not a value in the keys, right this, So any other difference that comes along is going to have to live up to their expectations. Equals value. Okay, so if it is in the key, then we know it's the same difference. So it is, if value 3, the indice, is less than value 3. Is less than 3. Watch this. I don't think we need all this now. That's comparing the indices, and that doesn't even add it if it's greater than... No, it's going to add all of them. It's going to add all of them. We could say... It's gonna keep all of them, but watch. Let's see what this gives us. I know it seems like we got a longer list now, huh? But we have the answer right here. The answer is the first thing. The answer is the first thing. We don't need to really maintain the other values, but in order to make sure it runs, really there's got to be some way you could say if it's greater than that. You could get it's not the top answer. Where are the keys? Value 1 is still the key, that's why. Yeah, there we go. So I don't know if this will work like this, but if it's going to sort it by keys. There's a 1 difference there. That's the key. So we don't want to say 1, but we know the zeroth position will always be the lowest key. So right there, this is our answer. Return look, this is the position, right? And we want to return the dictionary item with that position. The items, how do they want the answer here? Let's see how they want the answer. Like that. The difference, the weight, the indice, and the original number, right? Is that what they want? Index of the string of the corresponding number in string. Original corresponding number in string. Okay. Watch this. It is a dictionary, isn't it? It is now, the list is now a dictionary. We decided to go with a dictionary. And we want 2 numbers here. So let's say our list, which is return list, is going to equal list. Final weights list, sorted final weights list. Position 0, which is the key. And I need the number weight, which is in the temp weights list, right? At indice, this is the temp weight lists. Position 1. I just want to print this. Just to make sure we're coming up with the right number. Three. I'm gonna just get this value, just so I can have a and I wanna cancel this print for now. Okay, see, that's what I'm left with. There's my answer. I just got to work on how to return it. Okay, so that's my answer. How do I return it? The third indice. So that number is right. Third indice of the original list, right? Which is, no, of the weights list of temp, weights, list, position. Three. So this should give me the weight. Okay. I lost that list, didn't I? Wait list. There's wait list. Yeah, it's a wait list. Okay. Which is 14. Okay. It's 14. Okay, we got the weight. We got the weight. 14. Index of string and the corresponding number. Okay. Which is that. Which is... I want to make this easier for return, so... Let's make this easier to read, right? So that's 14. So what is that? This is num1 weight equals, right? And then we'll take this. Actually, we'll take the whole line. Let me move this over now. Now we got some more room. I know what I'm working with. I'm only working with 4 numbers here. I got more room. Okay, so we're gonna copy this whole line. Copy. This is quite a long code. Paste. Okay. So this is gonna be the second element, right? We did 3. And now we need 7. Second element. And that's going to give us the weight of num2, right? And then we need copy. Let's figure out. Let's assign that so we don't have to keep writing all that, right? So final results equal right? Let's just make sure. Print results. Right? And we're potentially going to get rid of these two lines. Yep. Okay. So now what we have is num1 weight equals results. 1 in the wait list. And that's the first thing they want. And then they want the num1 indice. Num1 indice equals that's just the number. Results 1. Num1 original equals end string. Results 1. Right? num2 results. That's the second one. Oh, what I'm doing. We can get rid of these print debugging statements now that we know that our code works. Okay. Now we need to return a list. Return a list. Of lists. num1 weight. num1 indice. num1 original. num2 weight. num2 indice. num2 original. Okay. It's because I'm returning nothing. Oh, compare weights, wait list. I'm returning this. The end string was not integerized. Okay. Okay. We're close. We're so close. The end string wasn't integerized. So what we're going to do is this is going to be an int of num1 orig. An int of num1 orig. Bam, I think that's what it's looking for. Let's try it. This is quite the code. Oh. List index out of range. It's not passing something here, right? Empty. It's not passing the empty test. If string it's empty, return an empty list. Else oh my goodness. We got the right answers. We know it. 143176 15796 should equal 13985 143,176. Oh, lowest difference. Lowest weights, the smallest difference of weights. With the smallest of weights. That adds a whole new spin to this. Alright, well, we got that far. And we gotta call it quits for now. You can see what part of the code we're missing. We've got all of it except one. We're not offering the smallest weights. We gave it the smallest difference with the smallest indices. But like my brother in chat mentioned earlier, the difference between 13 and 14 and 14 and 15 is still 1. And that's what we're getting caught up on here. It might be an easy fix. Let's just look real quick. If it's take me 5-10 minutes, we'll look. So let's go to the point where we're adding the weights, we get the differences. Temp weights list append difference. And the two weights. We can make temp weights list a dictionary with the weight as the key. With the lowest weights. So we gotta add up the weights too. We added up the indices, but not the weights. Where is on the list is that? Smallest weights. It says before that. Let's add the weights right here. No, let's add them here. So this would be weight list I. This would be this. Yeah. And then before we compare this, so we'll actually need that because we need to copy. Actually, we can just copy this one. Tab all this in. See, this was a 5-minute fix. Yeah, 5-minute fix. Watch this. 4 minus 4. Then we say if the weight is less, then look at the indices. If the weight's not less, just continue. Let's see, what do we pass? Passed 5. Passed the first one. Okay, so we did pass the first one. Okay. Well, we should pass all of them now. Let's index out a range. Oh, I'm sorry. Well, we took out our if we took out our if statement for if string equals return blank else. Ooh. How do we get that wrong? We did the weight too. 14,376, 14,376, 15. It's the second test case. It's the first one. Hmm. Okay, indices 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. '96 and 176. I'm getting 90. I'm getting 85 and 176. Am I missing the point here? Or do they have to be close? That's further apart. 85 and 176 and 96 and 176 are further apart. The 13th. The 9th. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 85. Eight and 5 is 13. Okay. I get it. Alright, we're gonna have to finish this later, guys. To be continued.